I am too smart. I am too smart. S-M-R-T. I mean S-M-A-R-T.
All right, everybody. Welcome to Chapter 6, Section 1. Chapter 6, there's a lot going on, okay? There's a lot going on. It's radical functions and rational exponents, okay? Very exciting stuff, all right? To start, we need to understand roots and radical expressions, okay? So we're going to take a look at this today. This is stuff that you have some familiarity with, but we're probably going to take it to an extent that is perhaps new or more complicated. So essential understanding here, really important that everybody understands that 5 squared is 25 and 5 cubed is 125, and that in the other direction it works the same. 5 is a cube root of 125 and 5 is a cube root of 625 and so on. Okay, this pattern suggests a definition of an nth root. All right, so we're going to take a look at that. If a to the n equals b, and all of them are real numbers, and n is a positive integer, then a is an nth root of b. All right. If n is odd, if there's more than one real nth root of b, denoted in radical form as the nth root of b, like that, then the only nth root of 0 is also the only nth root of 0 is 0. If n is even and b is positive, there are 2 real nth roots. This comes into like the positive and negative. What this is saying is that when we take the square root of 9, okay, we have to say it's positive or negative 3. But when we take the cube root of 8, we say that it's just 2, because we know that negative 2 won't work. We talked about this last unit. That is what this is explaining. When it's an odd root, we did it with cubes, but you can do it with 5th, 7th, 9th, any of that. There's going to be one answer. When it's even, there's going to be 2. Okay? Going to be 2. All right. Let's take a look at, we use a radical sign to indicate a root. The number under the radical sign is called the radicand. Yes, the vocab is important, because if a question uses vocabulary, you're going to need to understand it. The index, excuse me, the index gives the degree of the root. So if it's square root, we don't write anything. But with cube root, we put a 3 there. Fourth root, we put a 4 there, same thing. What are the real cube roots of 0.008, negative 1,000, and 1/27? Okay. Yes, you can do this on your calculator. Yes, it's more important that you be able to do this and understand it in your head, though. Okay. So this is just going over roots and what they are and what they mean. Let's go ahead and try. What are the real fifth roots of 0, negative 1, and 32? What are the real square roots of 0.01, negative 1, and 36 over 121? And then part C, explain why a negative real number b has no real nth roots if n is even. All right, go ahead and pause the video here. Try and get answers to A, B, and C. Go ahead and pause the video now. All right, you've unpaused. Hopefully what you have for A, you have the real fifth root of 0 in breaking news is 0. Okay. The real fifth root of negative 1 is negative 1. And the real fifth root of 32 is 2. Okay. For part B, square roots of 0.01 are positive and negative 0.1. Square roots of negative 1 has no real square root, and the question said real. So if you put I, yes, technically you're correct, but the question said real, so that would be a none. And then the real square roots of 36 over 121 would be positive or negative 6/11ths. Okay. For part C, any negative number multiplied by itself an even number of times will always be positive. Therefore, there can be no real nth roots where n is even for a negative number b. Okay, I'll say again, listen carefully. Any negative number, I'll tell you what, let me type this out for you so we got it. Okay, any negative number, hold on one second. There we go. Any negative number multiplied by itself an even number of times will always be positive. Okay, that should make sense. No matter what negative number it is, as long as it's multiplied by itself an even number of times, a negative times a negative is a positive. Therefore, there can be no real nth roots where n is even for a negative number b. Okay? All right. Finding roots. What is each real number root? This is problem 2. This is just finding roots. This is just a different way to look at it. This is a cube root, square root. This is a fourth root. And then this is the square root of a number squared. So, work backwards. You find a number whose cube is the radicand. That's all you have to do. Okay, working backwards is a really useful tool here. Let's go ahead, and this stuff should look pretty familiar. New concept, but old applications. Go ahead and try 2A, B, C, and D and get some answers there. 2A, B, C, and D. Pause the video. Get some answers for 2A, B, C, and D. Go ahead and do that now. All right, you've unpaused. Hopefully you got -3. For B, there is no real root. For C, -7 squared is 49, and the square root of 49 is 7. And here, there is no real root. You got to be real careful to read directions right now, because we know how to work with negatives, but they're asking for reals, and, well, they need to be reals. It says right here, it is tempting to conclude that the nth root of a to the n equals a for all real numbers a, but part D of problem 2 shows that that's not the case, and that's just right here. So part D of problem 2 is showing you that, sorry, hold on, that's this one, part C there, but if we look back at this page before, because we square this negative number, so that's not always true. If n is even, then the nth root of a to the n is positive, even if a itself is negative, okay? So it would be the absolute value of it. And that is this right here. So for any real number a, the nth root of a to the n is just a. If n is odd, it's just a. If n is even, then it's the absolute value of a. Okay? And we'll see what that looks like in a problem here in just one second. All right? So, let's look at it. Easy to overlook this rule for simplifying radicals. It's particularly important that you remember it. When the radicand contains a variable expression, you must include the absolute value when n is even, and you must omit it when n is odd. Okay? Must include it when it's even, must omit it when it's odd. All right? So here, for example, the square root of 16x to the 8th, the square root of 16 is 4. We know that, but it could be plus or minus 4. And then we have x to the 8th. The square root of that is x to the 4th. So we have that, and then we have the whole thing. It says you need to include absolute value symbols because the index of a square root is 2, which is even. Okay. However, the absolute value 4x to the 4th equals 4x to the 4th because x to the 4th is always non-negative. This is never going to be negative because it's even if x were negative, when we take it to an even power, it's going to end up being positive. All right. Here, the index is odd, so there's going to be no absolute values. We just simply take the cube root of each one of these things. And so we're left with a squared and b to the 3rd. Here, the index is even, so we're going to have some absolute values. So the 4th root of x to the 8th is x squared. The 4th root of x to the 12th of y to the 12th is y cubed. But because we have this 3 here, we have to take into account the absolute value. Okay, it's always positive when y cubed is negative. All right, because we can't take the square root of a negative number, or we can't take the 4th root of a negative number. All right, part 3 or got it 3. Let's go ahead and try those. Be careful with the absolute values. We'll work on them. They're going to seem difficult first. We'll get used to it. Go ahead and try 3A, B, and C. I'll give you a hint ahead of time. And that is that C is the only one with an absolute value in the answer. Okay? Go ahead and pause the video here and get some answers. Ready to go. All right, you've unpaused. You've unpaused, and hopefully you got 9x squared, a to the 4th, b to the 5th, and then the absolute value of x cubed times y to the 4th. Right? Let's take a look at the next page. Using a radical expression, so some teachers adjust test scores when a test is difficult. One teacher's formula for adjusting the scores is a equals 10 times the square root of r, where a is the adjusted score and r is the raw score. If the raw score on one test ranged from 36 to 90, what is the range of adjusted scores? Okay, so they take the raw score, 36, put it in here, square root of 36 is 6, 10 times 6 is 100. Sorry, 10 times 6 is 60, so that's the low end. Then we take 90, the square root of 90 is about 9.487, multiply that by 10, and we get a 95. The adjusted scores range from 60 to 95. So in problem 4, what are the adjusted raw scores, adjusted scores for raw scores of 0 and 100? Well, what's the square root of 0? Please say 0. 0 times 10 is 0. So that would be the adjusted raw score, or the adjusted score for a raw score of 0 would still be a 0. The adjusted raw score for a score of 100, well, 100 square root of that is 10, and 10 times 10 is 100. So the adjusted scores for raw scores of 0 and 100 would still be 0 and 100. Okay? That's it for the notes. I'll answer questions on the absolute value stuff in class. I'm sure that part was confusing. I will see you next time. Bye.